Hi everyone! So this is the second video on Structs. It was a pretty big topic, so I wanted to divide it up into multiple videos. I'm looking forward to going over this with you today. All right, here we go. So with Structs, there are stored properties, which is just a single value, but there's also something called computed properties, which basically means that we need to run some code to determine what the value will be. So here's our example. We have struct animal var type string. That's our stored property. But our var sound string, that is actually our computed property. So to determine what the sound will be, we want to check and see what our value is. So our type, we're saying if type equals dog, then we'll return bark. If it's equaling to cat, meow, otherwise unknown sound. So the program actually runs and gives you a different response for your variable depending upon what some other factors that it calculates prior to giving you your variable. So property observers are similar to computed properties, but they only run when a property is actually changing. They have a set of code that when the property changes, um, they will run at that point. So there's kind of two different ones. So there's will set, which runs a code prior to a property changing, and there's did set, which will run it afterwards. So our example here, we have a struct paper, and we have our var type string, and then var progress int. So once progress is changing, every time we say that it's changed, then the did set will run. So then I'll say print the paper is now whatever percent of progress we've now said it's changed to completed. So we'll show a little bit more details. So we create our example, English paper equals paper, type English in progress, so we set it to 0. So we print our English paper.type and our English paper, which progress, which at this point is equal to 0. And then when we update it to both 20 progress to 20 and then update it to 50, it will run that line, print that line. The English paper is now at 20% completed. English paper is now 50% completed. So another pretty cool thing is that strings are actually structs, and they actually have their own methods, and you can call these methods on a string. So we have our Lord of the Rings quote that we'll use here, and you can do Lord of the Rings.count, and that will provide the number of characters in the string. There's dot has prefix, which checks to see if the string starts with certain letters. There's dot uppercase and actually dot lowercase as well, but that will make all of the letters either completely uppercased or completely lowercased. And there's also dot sorted, which will basically make the string into an array and sort the characters alphabetically. There are lots of other ones as well, lots of other structs that, methods that the string can be used on a string, but these are some of the ones that you can use. So Swift actually allows you to create properties in such a way that they aren't actually created unless you need them. So you use the keyword lazy in front of the property, and then it won't actually create that until you call it and say, yes, I actually want to use that property now. So we have our example here, our our struct dog sound with its init, which is print wolf. And then we create another struct animal, and we're using lazy var sound equals dog sound, so we're calling that. And then when we create our examples below var cat, that one, since we didn't actually call dog sound there, it won't actually create that property. But in the line below, we say var dog equals animal type dog, and then we call dog.sound. Now it'll actually create that property. But prior to that, it actually never created it. So you can create properties and methods that are actually shared across every instance of a struct that's created. You use the keyword static in front of the var for any static variables. To access those static variables, use the name of the struct dot the name of the static variable, since it belongs to the struct and not actually the instance of the struct. So we have an example here, struct movies, var name, string, and then we have a static var number of movies. Now, any different instance of that struct that's created can access and use this number of movies. So now creator init, and then in that init we say movies dot number of movies plus equals 1. So it's basically going to count how many of movies we are creating, how many instances we are creating of this struct. So we're creating 3 different instances. We have Harry Potter, Lord of the Rings, and Star Wars. And then if you then print movies.number of movies, it should say 3. So if you want to make sure something remains private and can't be accessed except for methods that are inside a struct, you can actually put private in front of a variable to ensure that. It basically stops from being able to read that information readily. So, for example, we have struct ID, dog ID, and we have a private variable ID, which is an int that we will create, but we're also going to say, hey, I don't want just everyone being able to access it. So we'll just finish up our example of our name, string, create our init. Now we're creating an instance of it. So we say var fluffy equals dog ID, and then we just put our number and the name fluffy. Now if we say print fluffy ID, we're going to get an error. It says you put private in front. That means I am not just supposed to print this information out. Now on the flip side, if you use the word public in front of the var, then that will allow information to be read by any code out there. All right, and that is it for structs. There will be another video coming up for more practice problems on the information of this video. I really hope this helped, and I wish you luck as you learn Swift.